Okay, so to determine the derivative of sine x from first principles, I've got my sine x here, and I have my first principles derivative definition. So into it I've had to put sine x as the basic function, and then sine x with x plus h as the argument. So I've got that little nudge that I need to work out through this limit process. So when we did this with polynomials or anything that satisfied the power rule, there was some sort of algebra trick that was able to extract the x and the h from this first term so that something from this was undone by this one at the back. Now this is a little tricky because it's a sine. So you would need something that allowed you to take the sine of a thing plus a thing and write it as a sine of this and a sine of that, plus any other bits. So you may recall, hopefully, from your advanced functions course, the addition identities for sine. They look like this, that the sine of x plus h is going to be sine x cos h plus sine h cos x. I'm going to let that sink in there. This is a thing that you did definitely in advanced functions. So I'm going to use this here. I'm going to make that replacement. So my derivative, df by dx, is the limit as h goes to 0 of this thing up here. Instead of sine x plus h, I'm going to write sine x cos h plus sine h cos x. Then I have a negative sine x that was here the whole time. All over h. Okay, good. Now, if I look at this, I don't have a stray sine x, right? I don't have a sine x to subtract from that, but I do have one here, and I have one here. So what I'm going to do is I'm going to bring them together so that they're sitting right beside each other so that I can do some factoring. So in my next line then, df by dx is limit h goes to 0 of sine x cos h minus sine x, and then I have this thing plus sine h cos x. And the whole thing is over h. But for my convenience, I'm going to split it into two fractions. I'm going to keep one over here like this, and I'm going to keep one over here like this. And so what I'm going to do in the next step is I'm going to put my limit over here as well. So I'm going to try and do these limits separately. Why? Well, you'll see in a minute. It's going to help me figure out which parts of these things survive and which parts don't. So in my next line, df by dx is, I have a sine x here, so the limit as h goes to 0. I have a sine x in this term and this term. I'm going to pull it out. That leaves me cos h minus 1 over h. And in this term, I have the limit as h goes to 0 of a cosine x with a sine h over h. Alright. Now, do you notice that this sine x does not have an h in it? So this thing has no effect on it. So I'm just going to write it on the other side. So df by dx is sine x limit as h goes to 0 of cosine h minus 1 over h plus cos x. Same thing here. This doesn't have an h in it, so this operator isn't going to affect it. Just let her slide in front. Limit as h goes to 0 of sine h over h. So we've reached a bit of an impasse. I don't have an h here to cancel that. And I don't have anything here to cancel that, right? I can't divide these things away. So I'm stuck at this line until I remember that I can evaluate these limits manually. So the way you're going to do that is to actually try some numbers that approach 0. So I'm going to do this one first. I'm going to try h equals 0.01. So I'm going to put that actually in there. Cosine of 0.01 minus 1 over 0.01. And if I do that, make sure your calculator is in radians when you do this, otherwise it won't work. So the cosine of 0.01 is 0.99995,004. If I subtract 1 from that, I get something in the 10 to the negative 5, so it's very small. Divided by 0.01 gives me negative 0.00499999583. Okay. So as with all limits, I'm going to do this 3 times. And if I can get a pattern forming here in 3 attempts, then I will have a rough idea of where this limit is going to. So I'm going to try the next one. I'm going to get even closer. H is 0.123. I'm going to keep 3 zeros and a 1. So I'll be typing in cosine of 0.123 minus 1 over 0.0001. So cosine of 0.00001 equals 0.999999995 minus 1 is something to the 10 to the negative 9 divided by 0.0001 gives me negative 0.00005000001. Okay, that's getting real small. That's almost gone. It looks to me like these numbers are creeping up on 0 from below. So let's try one more time just to make sure we've got a pattern going. Try h is 0.12345 5 zeros and a 1. So if I put that into the calculator, cosine of 0.123 5 zeros and a 1. The calculator I'm using has already rounded that to 1. Minus 1 equals, and then divided by 0.12345 zeros and a 1 gives me negative 0.0000005. So as I look at these numbers, it looks to me that as h goes to 0, cosine h minus 1 divided by h is also going to 0. So I'm just going to take this thing here and I'm going to put a great big strike through it and let myself know that that vanishes. Okay, so I'm going to clean this off and then I'm going to try and do the same thing for this limit here. I want to see if that limit is actually worth something if I do it manually. So here we go. We're going to try and evaluate this one. So same h values. Try h is 0.01. So I'm going to do sine of 0.01 divided by 0.01. if I type that into the calculator, sine 0.01, something teeny, divided by 0.01 gives me 0.99998333334. All right. Get closer. I'm going to go with 3 zeros and a 1. So I'm going to take sine, put in 0.1230 zeros and a 1 over 0.0001. 1, 2, 3 zeros. Something also tiny divided by 0.0001 is 0.99999999983. That's a whole bunch of 9s. It looks to me like these numbers are creeping up on 1 from below. So just to confirm that, you always do three lines. 3, 4, 5. So I'm just going to drop that into the calculator. Sine of 0.12345 zeros and a 1 divided by 0.12345 zeros and a 1 gives me 1 if I round it on, well, that's what my calculator rounds it to. So what I've got there is that as h goes to 0, sine h over h goes to 1. So I'm just going to make note of this here. This thing goes to 1. I'm going to erase this little mess here because I need to do a little bit more work. But I'd like you to take note of this thing I just wrote down there. The limit of h going to 0 of sine h over h, this thing is called the fundamental trigonometric limit. Fundamental. It's a lot of words. Trigonometric limit. Okay, and we are going to take advantage of it again when we do the derivative of cosine. But it's something that you should add to your formula sheets or the archive of important facts that you keep in your Nergin so that you can do these types of derivatives later. So just to finish off, what I've got here is df by dx equals this sine x here multiplied by a limit I did manually that turned out to be worth nothing. And here I have a cosine multiplied by a limit that I ultimately figured out manually was worth 1. So altogether, my derivative then, sine x times 0. Well, 0 times anything is gone. And 1 times cos is just a cosine x. So it turns out that if your function is sine x, then the derivative is cos x. So I'm going to erase this, and we're going to try and do the derivative of cosine and see what we get for that. All right, so filling my cosine into the first principles derivative setup, I've got a cos x plus h there, and we started the sine one by using the sine addition identity. So to do this one, I'm going to need the cosine addition identity, which looks like this. Cos of anything plus anything is cos of the first, cos of the second, minus sine of the first, sine of the second. Again, that's something you did in advanced functions, and you could look it up again on Wiki or whatever so that you can confirm that that's true. I'm going to take this thing and I'm going to drop it in just like I did for the sine derivatives. So dt by dx is the limit as h goes to 0 of this horrendous thing. So cosine x cosine h minus sine x sine h minus cos x, which was already there, all over h. Now this should be looking pretty familiar after having just watched the sine example. I don't have a cosine x to cancel this cosine x, but I do have two terms that contain them. So I'm going to pop this one over here so that I can do some factoring. So dg by dx is the limit as h goes to 0 of cos x cos h minus cos x. So I just brought this one up, put this one to the back, and it's all over h. But just like the sine one, I'm going to try and break this into two pieces. So I'm going to start by putting it into two separate fractions, both over h. Then I'm going to throw my limit in here while I also do some factoring. So dg dx equals the limit as h goes to 0. Both of these terms contain a cosine x, so I'm going to factor that out. And that leaves me with a cosine h minus 1 over h. I have a negative here, so that's subtract the limit h goes to 0. This one contains a sine x piece, sine h over h. So again, just like in the sine example, this does not contain an h, so it's not affected by that operator. Neither does this. So I'm just going to write them in front. Is cosine x limit h goes to 0 of cos h minus 1 over h, subtract sine x limit as h goes to 0 of sine h over h. Now I'm back to the same place where I'm going to have to use the manual limit technique to actually evaluate these, but I've already done it, and if you want to see what the answers were, you can go back and check the last video. This thing here you should start to recognize as the fundamental trigonometric limit, which says that the limit of h going to 0 of sine h over h goes to 1. The sort of corollary to that is that this limit, the limit as h goes to 0 of cos h minus 1 over h, vanishes. And if you want to see that actually done, you just rewind about 2 minutes in this video and you'll see me actually do that manually. So what I end up with net is that my derivative dg by dx is equal to this cosine here multiplied by a limit that I ultimately found was worth nothing, minus a sine multiplied by a limit that I ultimately found was worth 1. So altogether, 0 times a cosine is worth nothing. 0 times anything is 0. So that's gone. And the only thing that's left is 1 times sine, which is just sine, and it happens to be negative. So having gone through the process, I've just shown that if your function is cosine of x, then its derivative is negative sine x.